Hello, ladies and gentlemen. Thank you very much for watching. In January 2013, the Puget Sound Professional Chapter of Engineers Without Borders sent a team of engineers down to a remote region in central Nicaragua. The team addressed aspects of a very important issue that has been and currently is affecting the health, lives, and futures of many communities in the highlands of this amazing country. The sad fact is that morning mocha many of you may have enjoyed could have caused a lot of pollution in a river somewhere in the beautiful coffee-growing regions of the world. This will make more sense in a few minutes. We're talking about coffee because if a farmer is lucky enough to live in the regions where coffee is willing to grow, then that farmer will want a relationship with coffee. There have been wide swings in the price of coffee worldwide in recent years. Despite this, coffee remains a crop of choice for farmers where it can be grown. Over frijoles, beans, over maracuya, passion fruit, and even over cacao for making chocolate. Coffee is the delicate, picky plant that farmers often want to grow on their land. But there is a problem. A big problem that occurs when coffee is processed on small, rural Nicaraguan coffee farms. This is where the Engineers Without Borders team comes in. This is how many people who are able to grow coffee get that coffee to market. This represents the lowest level of technology of coffee process. Coffee cherries are carried in large quantities called quintales. One quintale weighs approximately 100 pounds and comes in a sack exactly like the one you see on this young man's shoulders. This is a place where can be found the coffee cherry depulping device. These depulpers are usually owned by a collective of people as they are expensive. The seeds, or coffee beans, are then put back into those bags to ferment and afterwards sun-dried. This basic depulping process and dry fermentation represents the lowest level of sophistication of coffee process. Therefore, it yields a poor quality of coffee. Here we see how a farmer can obtain a much higher quality end result of a coffee harvest. This is a wet mill beneficio. This is the kind of system that the families of the village of Tierra Nueva want to see on their land. This includes the depulping process you just saw, but now the fermentation phase takes place in water tanks for about 12 to 18 hours, and then the coffee is rinsed like you see here. But here is the problem. This is why the team from Engineers Without Borders is here. The coffee beans have a sticky mucilage that must be removed before the coffee can be transported or sold. But the coffee rinse water being generated is highly murky and pollutant. It is called by the locals agua miel, which means honey water or sweet water. Often this water goes into nearby rivers in huge volumes, and then into downstream drinking water systems. This region produces some of the highest quality coffee in the world, and it also produces world-class industrial-level coffee waste. Here is a very basic breakdown of that murky, cloudy coffee rinse water. This data represents the waste from farms that still may qualify to sell their coffee as organic or shade-grown or free trade. There is no doubt that this is a high-level industrial-grade wastewater and a potential problem. We got our equipment and our act together and got the team on a flight and sent down to Managua, Nicaragua. So who is on this team? First, our fearless leader is Set. She is a hydraulic engineer with West Consultants over in Bellevue. Dan is a propulsion engineer with Boeing and the past president of the Puget Sound chapter of Engineers Without Borders. Max, who has a wastewater engineering background and is currently a traffic engineer with Pertit up in Everett. And I am Patrick, and I am with Appia Engineering Consultants. I have a civil, environmental, and sound engineering background. And here we arrive in Tierra Nueva, home to 150 families. You can't see it here, but we are standing next to a water tank, and Carlos, one of the civil engineers, is pointing out the source of the water. It's an ojo de agua, which means spring source. It's 14 kilometers away and 200 meters above where we are standing. This is very near that ojo de agua, 14 kilometers away and 200 meters above where we were standing. We felt it was really important to understand all the hydrology and hydraulics of the area before we could begin our design or choose a good location, so we did a lot of hiking around. Then we came to the site where they had hoped to put a wet mill coffee process. It was a centrally located area, and there will be a road constructed where we are standing in the mud. The site has water access and is a good distance from the nearest stream. So we sat down and got to work. We took soil and water samples and did infiltration testing. We also performed an extensive field survey of the area to create a topo map. We were lucky enough to run into the president of Sikosamac, which is one of the coffee cooperatives centered in Matagalpa. The purpose of the cooperatives is to commoditize the coffee. They buy it from farmers and act as a broker between growers, processors, buyers, and exporters. Here he is showing us a roasting device that he has next to a coffee lab and tasting room on site. Buyers come from all over the world to sample test batches from here. So now what? Now we measure twice and cut once. That's what. We do a lot of literature research, we do a lot of math, and we carefully quantify all of our assumptions. We make 2 or 3 design alternatives for the site. We plan to return to oversee a completed construction by the beginning of coffee harvest season 2014. Thanks for watching, and I hope you have a really great day.